Alright, friends and neighbors, time to get back to OSPF. This time we're going to talk about some of the more advanced ideas in OSPF, and they're not really advanced, but they just make, an OSPF topology a little more real world and maybe a little more powerful and a little more controlled. So specifically we're going to talk about designated routers, backup designated routers, priorities for those routers and the router ID, and then maybe how to redistribute routes within an OSPF topology, or at least into an OSPF topology. So let's get underway. Now let's remind ourselves about a couple of things here. First of all, we have OSPF neighbors, and OSPF neighbors just share a common network or segment. And that is just two routers that are connected to the same network, and they both want to do OSPF, and they look like they want to do the same kind of OSPF. They may or may not be authenticated, who cares, but really the big deal is that they're both connected to the same network and they both see each other. So any network will have neighbors, any network I should say, with a couple of routers, right? If they're both doing OSPF, one says, hey, I want to do OSPF, and I want to do OSPF too, hey, let's be neighbors. So they're automatically neighbors, but that's only part of it. So the minute you have a couple of neighbors, you have the potential to swap routing information. Now adjacency is a little bit different. So unlike our angles up here that are adjacent, OSPF routers that are neighbors don't necessarily have to be adjacent. The only time we establish an adjacency is going to be when two routers decide that they're not just neighbors, but they're willing to swap route information with each other. Now the minute you have two routers there, right? So let's say you just got the two. Well, one of them is also going to be the designated router, and then one will be the backup designated router. And then the deal with the designation here is that we elect a router to be a designated router by the priority that's set. The default is 0. We'll see that here in a second. And then, of course, that router is going to generate the link state advertisements for that particular network segment. Okay, so let's talk just a little bit more about designated routers. So the minute you have a broadcast or a non-broadcast multi-access network, bunch of routers connected, you're going to automatically have that designated router. You have two routers, then you got a backup designated router too. And then the hello protocol, right, those hello messages that we talked about in a previous video, those are used to elect the designated routers. Okay. The designated router has a couple of jobs. One is we want to have somebody that does the network LSA for that, and that's all of the routers that happen to be connected to that particular network. Now the designated router is automatically adjacent to all of the other routers on the network. Not just a neighbor, but automatically adjacent. And that makes sense because it's originating right on network information. Okay, that's a lot of talk. Let's take a look at our topology. So here we have an OSPF topology. Now I generated this so that we can create some problems and then we can solve the problems. Now it looks complicated at first, but let me show you around the place. So first up, let's take a look at some of the areas that we might have. So right here I've got the 172.16 address space, and maybe right here we could call that area 0. Okay. Now we've got all of this other stuff over here, and we got, well, this segment, the 30 net, ooh, 3 routers connected there. We'll have to figure out what to do about that. And then we've got a couple of other spots here that we'll have to solve. So maybe what I'll also do is say, well, this whole thing right here, and I want to be a little careful on how I draw this. Might be area 51. Now I'm trying to leave this out over here because this is going to be a special little spot over here. This is sort of off by itself, and maybe what I'll do is sort of drag this down a little bit to make it clear that it's not part of the area. Now we've also got the 24 net here, and so this is my simulation of Time Warner or Spectrum. So maybe this right here is sort of our demarcation point for the inside network, the autonomous system on the left, and then maybe the rest of the world. Now we wouldn't do OSPF out here. We would default route to it. Maybe we'd do BGP or something of that sort. But this is the rest of the world. So our OSPF concerns are going to be limited to here, but we do need to solve the default routing problem. Okay, so I think that does it for our topology explanation. Let's do a little OSPF and we'll talk about what goes on. So I'm going to take a look at this router right here. And what we're going to do is light up some OSPF stuff, and then we'll take a look at some of the configuration options. And again, we're worried about really three things: router priority, the designated router, and then some router IDs. Router IDs. So first up, we'll do router, and you can see my IP addresses here. We've got the 20 net and the 30 net. So we've got our router OSPF process, and all that I'm going to do initially is turn on OSPF up here. And both of these networks are going to be in area 51. So we'll do it both ways. We'll say area 51, and then we'll also say, whoops, we'll say area 0.0.0.51. So you can do it either way. And so that is our base OSPF configuration. Now at this point, this router is all by itself and generating OSPF messages. So there's an OSPF message. Let's actually make sure that we got some filters turned on. We do. Okay, good. And we'll take a look at the two OSPF messages that are leaving the router. No, I've got OSPF on way on the outside too, but we don't really care about that. Okay, so here's the messages leaving router 4. So we've got one going to switch 8 and one going to switch 7. So let's take a look at this one. And we can see a couple of things by looking at the OSPF hellos. This is just OSPF hellos because we haven't found any other routers yet. Remember that we're using this multicast address for OSPF. We can see the area. We can also see the router ID. Now this router ID is 3254, and that is going to switch 7. That's on this side. Okay? All right, and that's really all that we have at this point. That's really all that we care about. The type 1 just means that it's a hello message. Now let's take a look at the one going to switch 8, which is on the other side. We can see the source IP address has changed, but take a look at the router ID. The router ID is the same. So going out either side of router 4 is the same router ID. And so it's a little confusing if you're looking at traffic on either side that the router ID is tied to a particular IP address. And so that's what OSPF does. It automatically selects a router ID that you might use. Okay, so that's one thing. And then we can see there that we're dealing with area 51. All right. Well, let's go real time here, and we'll beef up our topology a little bit. Now, the first thing that I'm going to do is I'm going to turn on OSPF on these two routers here, and we'll do the same thing. So we're going to do, now remember that this router 5, we'll do this one first, is an area border router. So we might actually say that. So router 5 is an ABR because it's connected to not only area 51 but also area 0, which is our backbone area. So let's do router OSPF, and I'll use process 1. Remember, the process is independent of or specific to a particular router, so it doesn't matter what you use on the other ones. It doesn't matter if you use the same one throughout your topology. And I'm going to say network. Well, let's do area 51 first, so 192.168.30.0, and our wildcard mask, and area, area 51. Okay, good. Now we can just type the whole thing again. Now let's do our other area. And this would be the 16 net, or 172.16. Whoops. 255, area 0. Let's see if we got that. So let's clear up. So that's what the command looked like when I did it. Okay. All right. Now we will go over to router 3. And we'll turn on OSPF here too. was I doing? Router OSPF 1. Now this one is connected to the 30 and the 40 network, and that's all that I'm going to do at this point. Remember that we want to leave this one off by itself on purpose. For right now, anyway. 30.0. 000.255. Area 51. And oops, there we go. Now, what should happen is that theoretically all of the routers should learn what we know. Now, I know that I have OSPF running here. You saw that blip coming over here. So router 6 knows that it's in area 0. We've got router 5, router 4, router 3 configured. So let's see what router 5 understands at this point. Show IP route. Okay, so we've got, so I'll explain this guy here in a second. So we've got the 40 net, we've got the 30 net, the 20 net, and the 172.16. So what we have learned about on router 5, we've learned about this network all the way over here, obviously the two directly connected networks, and then this network here. And then we'll just for fun, from the perspective of router 3, what do you know? Well, not as much. We've got an inter-area route, which makes sense. That's from the backbone via the area border router. And then we've got OSPF routes for the 20 net. All right, we've got, well, what are we doing with the 30? Well, the 30 is directly connected, and then we're directly connected to the 40. So router number 3 has learned everything about the network that it can at this point, or the networks. So far we've seen that a router will generate a router ID automatically. And now that we're communicating, let's take a look at one other thing. Let's take a look at something going into the network here, and who is the designated router? Well, here we see that we've got a designated router of 30.254 and a backup designated router of 30.252. So that means that the designated router is here and the backup designated router is here. Now by default, what happened is they did an election based on priority, and if the tie is, or the priority is a tie, then we elect whoever was up first. Now this router is a fine router. There's nothing wrong with this router, except maybe we don't want to use this as the source of information. Maybe a better source of information would be router 5, or maybe even router 3, because there's more stuff over here. So how do we fix that? Well, we're going to do two things. We are going to specify the router ID, and then we're also going to specify the priority so that we swap who is the designated router. So again, we want router 5 here to be a designated router, and we're going to go ahead and make router 3 the backup designated router. So let's do a couple of things. Alright, so the first thing we want to do is give this guy an IP address that is tied to the router that we're going to serve as the router ID. So for that, we're going to use the loopback. So I'm going to say int loopback, we use, oops, that's not right. Let's do loopback 1. And I'm going to say IP address 10.0.0. This is router 5, so I'm going to use 5. Oops. Like that. Now, for those of you who don't know what loopback interfaces are for, they're management interfaces, but the cool thing about loopbacks is they're a logical or virtual interface. They're not tied to a physical interface. So a lot of times we use them for management. You can use them for routing information. In our case, we're going to use them as a router ID because it just makes it easier when you're looking at system output or when you're looking at packets to know that this particular IP address goes with this router, and it's going to advertise it out, all of its interfaces. So the next thing we need to do is say router OSPF 1, and we're going to say router ID 10.0.0.5. Okay, so that's the first thing that we're going to do. And we might as well do that with this guy over here. So So we're going to say config t, and I'll say int L1. It looks kind of funny, but what that really is of course the loopback one. And we'll do the same thing. IP address 10.0.0.3. And there we go. And we'll go to our router OSPF. Oh, that's not going to work. Router OSPF 1. And we'll say router ID 10.0.0.3. Now none of these changes are going to take effect until we change our OSPF process. But what we'll do first also is we're going to well, our second change that we wanted to make was we wanted to change the designated routers. So what did we want to do? We wanted to make router 5 our designated router and router 3 our backup designated router. Now we could use the loopback interface to do that, but then we got to advertise loopback routes and all that. I'm not going to worry about that for right now. So what I'm going to do, especially since this one's on the my area border router, I am going to say, well, I want this interface to be associated with the designated router or the interface from which the routing information is sourced. So I'm going to go to int f0/0, and I'm going to say IP OSPF priority 100. Now it's any value. Here you've got a range that you can use. I'm just picking 100. Okay, and what that says is that, look, everybody here that's connected to this network, all of those neighbors and the adjacency that we're going to establish, here's the information from this router interface. We want this one to be the backup designated or the designated router. Why? Because its priority is going to be the highest. So let's do the same thing with this router over here. Now this will be int f0/1. So whoops, int f0/1, and we're going to say IP OSPF priority. We'll say 99 for this one here. Okay, so a quick look at my config. There's my loopback interface, right? My two normal interfaces, and then I've added this priority here on the 30net, and then we're advertising everybody else. And router 5, the only difference here is that this one is on, well, it's the ABR, so it knows about a couple of areas. But here we've got a loopback, and remember that now when we say we want to use this as the router ID, it's going to be advertised out all the ports attached to this router as the advertising router, but or as the ID for the router. But it doesn't do anything until we either clear or reload our process. So we're going to do this: clear IP OSPF process. Now you maybe don't want to do this on a on a running router that's routing lots of packets, that's busy production router. IP OSPF process, but we're going to speed things up a little bit here. And maybe since router 4 is connected to area 51, or at least the 30 network, we'll do the same thing here. Just to make sure everybody's on the same page. All right, we'll give that a second. All right, we can see a couple things. We can see these neighbor numbers now. Those are different, right? Instead of using the IP addresses that were used, just attached to the interfaces. But let's make sure that we, first of all, that we know all the routes. Say that. So there's the 20net, the 30net, the 40net, the 172.16. We've got now this loopback interface that we're using. Okay, that sounds pretty good. Let's also take a look at our OSPF information. So we'll see who our neighbors are. And take a look. So this is router 5, so it now knows that there's a neighbor out there. Take a look at that priority. So I didn't change these priorities. These are the default priorities of 1. Now we've got 99 being used. That's awesome. And so that might make a change for us elsewhere. Now we can take a look at a couple of other commands if we wanted to. We could say show IP OSPF database. This is everything. Right, here's all the stuff for area 0. And then down below we see all the stuff for area 51. I'm not going to worry too much about that right now. But let's see the other impact inside the router packets, or the packets coming from the router. So if we look at what's coming from router 4, now we take a peek right here. Now this is all the way, this is on a different network, right? Now take a look here. The designated router is 20.254. Remember that the designated router for a particular network, where you got a bunch of routers, this is really about who's in charge of the information there. Now there's nobody else here but this particular router, and there's the priority. All right, so that's not reflective of the, well, it doesn't have anything to do with the changes that we just made. We need to see stuff going out on the 30 network. So we take a look here. Take a look at our designated route, 30.252. Well, that's this interface right here. It's now router number 5. And then we got our backup designated router is 30.253. So that is exactly what we wanted. And then here we've got our neighbor IDs. So those are the two changes that we wanted to make. So now we see that the information is being sourced by router 5. And in the absence of information from router 5, we would get it from router 3. All right, so that's how you would do it. That's the router ID and the router priority. And, again, if we take a look at the IP OSPF neighbors, on another router, we can see that this router here just has the two neighbors, right? One on the other side, router 2, and then its neighbor up here. Why is that the case? Because, well, we are just swapping information with that particular router. We can see the priority now is 100 right there. There we go. So we've got, oh, sorry, I was pointing at the wrong router there for a sec. So we got router 4 and the other router, router 5. There we go. Okay, so this video is getting a little bit long now, so I think we're going to break this into two parts before we handle this poor little lonely network down here, and then also our default routing. So stay tuned for part 2 of this router IDs, priorities, designated routers, and redistribution of routes.